Hello students, this is Mr. Deaver, and in this video we are going to talk about equivalence point. We saw in our last video that when we mix acids and bases together, they react or neutralize to form water and an ionic compound or a salt. So let's think about for a second what happens if we mix an acid and base, but we add a lot more acid than base. What are we going to see in our products? Well, are we going to see more H's or OH's? We're going to see a ton of H's, right? Since we've added a lot more acid, we're going to have a lot of H's, only a couple OH's, and all those OH's are going to be able to react, but there's going to be some excess H's. And of course, when the H's and OH's react, we're going to get water. So we're going to have some H plus ions and some water, but really no OH's because they all are going to react. And of course, notice that I'm not putting in the A and the B and the AB. Let's just focus on the H's and the OH's and water right now. What about if we add a lot more base? What would you expect to see? Well, since there's a lot of OH's, a lot more OH's, all the H's are going to be able to react and make water, and there'll be excess OH's. So we'll see something like this. But what about if we add about the same amount of acid and base? Well, if there's the same number of H's and OH's, then every H and every OH is going to react to make water. And we're just going to have water and no H's and no OH's. All right, so when we mix an acid and base together, and if we get the same number of H plus ions and the same number of OH minus ions, we call that the equivalence point. All right, now why do we care about equivalence point? When do chemists use it? It's actually very useful if we don't know the concentration of an acid and base, if we have a solution with an unknown concentration. So let's say we have a solution of hydrochloric acid, and we don't know what the molarity is. Maybe it's 10 molar. Maybe it's 0.00001 molar. We don't know, and there's a big difference between those two concentrations. So what we can do is neutralize that acid with a base, like sodium hydroxide, for example. And if we know the concentration of that base, if we know how much base we added, and if we know the volume of our acid, then we can use this idea of equivalence point to figure out the unknown concentration. Let's see how to do that. All right, we have to first look back at molarity, and then we're going to work to derive the equation we're going to use to solve problems like this. Right? We know that we use molarity to measure concentration, and our formula for molarity is moles divided by liters, or N divided by V. So let's first rearrange this equation so that we get N, or moles, all by itself. How do we do that? Well, we've learned in a previous video that we can do something called cross multiplication. And cross multiplication is just a way to rearrange this equality. When we do cross multiplication, we get N times V equals N times, what is this down here? Well, we know there's an invisible 1 down here. So we get N, or molarity, times V, and that equals N times 1, which is just N. So M times V equals N, okay? All right. So now, what is the moles of acid going to be equal to? Well, moles of acid is just going to equal the molarity of the acid times the volume of the acid. So notice that we have a little a down here, which stands for acid. So Ma is molarity of acid, and Va is volume of acid. The moles of base is going to equal molarity of base times the volume of the base. Now, if we're at our equivalence point, then moles of acid equals moles of base. They cancel out. And of course, we saw in our visual in the last slide that at the equivalence point, these moles of H and OH are going to react to make a lot of water. Okay, so let's see if we can put all these equations together. We know that Ma times Va equals moles of our acid. We know that if we're at our equivalence point, moles of acid equals moles of base. Okay, that's what the equivalence point means. Its definition is the same number of H plus and OH minus. And we also know that our moles of base is equal to molarity of base times volume of base. So now we can just simplify this equation, get rid of the middle part, and this is the equation we're going to use. At the equivalence point, molarity of acid times volume of acid equals molarity of base times volume of base. So now we can use this equation to answer the problem that we saw on the last page, right? We know 3 of these variables, and we can plug them in and solve for the other variable. So let's do that now. Let's start with the molarity of the acid. What is the molarity of the acid? Well, we don't know that. That's what the problem is asking us for. So that's going to stay as Ma for now because we can't plug a number in for that. What about the volume of the acid? Right? Tells us that we have 125 milliliters of HCl. So that's our volume of the acid, 125. Now, remember that in the past, we've often had to convert from milliliters to liters. We could do that here too, but since both volumes are in the same unit, we don't have to convert them to anything. But if one of them were to be in liters and one in milliliters, we would have to convert them to be in the same unit. What about the molarity of our base? We know that sodium hydroxide is a base because it has an OH, so its molarity is 0.1 molar. And the volume of the base is 54 milliliters. All right, so we've plugged everything into our equation here. Now we need to solve for molarity of acid. That's the unknown thing. All right, well, let's first simplify this by multiplying these two things together. Okay, so 0.1 times 54 is 5.4. So molarity of our acid times 125 equals 5.4. Now we have to get molarity of acid by itself on one side of the equal sign. How do we do that? We're going to divide both sides by 125. And when we do that, what's going to happen to the 125 on the left side? It's going to cancel out. And that means that we'll be left with molarity of the acid by itself on one side of the equal sign. And on the other side, we're going to have 5.5 divided by 125. Put that in the calculator, and our answer is 0.043 molar. So we use this equation because we know that at our equivalence point, moles of acid equals moles of base. So if we have a situation where we have an unknown concentration, we can neutralize it with a base, and as long as we know 3 of these variables, we can use this equation to solve for the missing one. Okay, there's some more practice. Get to it.